Now we can discuss the process of science. We use what is known as the scientific method, and in this class we will ask that you follow this method precisely, while in the field there is some flexibility to this method. There are 7 steps to the scientific method. They are: number 1, observation; number 2, formulate a hypothesis; number 3, design an experiment; number 4, execute experiment and collect data; number 5, draw a conclusion; number 6, accept or reject a hypothesis; and number 7, design a new experiment to continue testing your hypothesis. After you have executed an experiment, you should also ask yourself, how can I further test this principle or try to further explain my observation? This ties into step number 7. We use 2 types of logic in science: inductive reasoning and deductive reasoning. Deductive reasoning is what we use almost every day. It uses an if-then statement. If I eat breakfast, then I will not be hungry at 10 a.m. If I study for my test, then I will do better on my exam. This logic is based on experimentation and begins at a general observation that can be applied to a specific situation. This contrasts from inductive logic, where we start with a specific observation that we apply to a general situation. An example of this could be, a dog bit me, therefore all dogs bite. In general, inductive logic is more open to errors than deductive logic. Now let's test what we've learned about the process of science. Which of the following are qualities of any good scientific hypothesis? When you are ready, hit play on the recording again to test your answer. Good job! A hypothesis must be testable and falsifiable. Remember what I was talking about with what science is. We have to be able to experiment on it. We can't make up a hypothesis that states that there are aliens living in Pluto if we don't have the access to be able to test it. Also, with that falsifiable, you can't make the inverse true. It would be almost impossible for us to make a hypothesis that says that there are no aliens, because we are unable to falsify that statement. For practice, I want you to read the snake case study in your textbook and identify each of the steps of the scientific method. Write down these steps along with a description of the experiment for that stage. For example, step 1 is observation. What was the observation that led researchers to do this experiment? Bring this to class along with your other questions you have answered. This is the end of chapter 1. Let's review the objectives for this chapter. Are you on your way towards meeting these objectives? Which of these objectives are you still the most confused on? We will call this your muddiest point. Write down your muddiest point and bring it to class on a separate sheet of paper. When we get to class, we will do a mini lecture on these muddiest points, so make sure it's separate from your notes so I have the ability to collect it. Lastly, here is a list of supplemental materials that may help you work towards the objectives that you're still working on mastering.